Hello, grade 8. This is Mrs. Lopez, and today we will be working on lesson 5 negative exponents and the laws of exponents. But before we do that, as usual, I would like to review several simple rules that we already know regarding exponents and operations with exponents. So the first one is 4 to the third times 4 to the fifth. Again, this is a number that has the same base and multiplied by itself 3 times and then 5 times. And so that is 4 to the power of 3 plus 5, which is 4 to the 8th power. Second rule, 8 to the 8th divide by 8 to the second. Both numbers have the same base and different exponents, and they have been divided by each other. That means that if I wrote 8a's here and 2a's in the denominator, I would simplify a over a, that makes one whole, and I will end up with a to the sixth power. So what that is a to the power of 8 minus 2, and that is a to the sixth power. Next one, 2 and 8 tenths to the third power and to the fifth power, raised to the fifth power. What that is I have three groups of 2.8 multiplied by itself, and then that is multiplied by itself 5 times. So that is 2 and 8 tenths times 2 and 8 tenths times 2 and 8 tenths multiplied by itself 5 times. That means that I will have to write that 5 times. So basically what it is, I'm going to just simply multiply the exponents of 2.8. So 2 and 8 tenths to the power of 3 times 5, which is 15, right? 2 and 8 tenths to the 15th power. Next one, x to the third, y to the second, raised to the sixth power. So we are raising everything that is inside the parentheses to the sixth power. That makes x to the third to the sixth, which is a multiplication, right? And y to the second to the sixth. And that is going to be x to the 18th and y to the 12th. Another rule here is when we have a divided by b and all of it is taken to the power of 3, it means that I will have to take a to the power of 3 and b to the power of 3. The last rule that we learned just in the previous lesson is that any number to the 0th power is 1. So for example, if I were to take 5 to the 0th power, that is going to be 1 whole. Here comes our new rule. Let's simplify this following expression here. 5 to the 4th over 5 to the 6th. So I'm going to write it out. 5 times 5 times 5 times 5. And on the denominator, I have 6 of them. Okay. So now, just like in our previous rule, we are going to simplify our 5s that make 1. So this is 1. Okay, so what I have left in the numerator is 1, and in the denominator, I have 5 to the second. Okay, now let's apply the rule that we learned previously. When I have 5 to the 4th divided by 5 to the 6th, I'm going to subtract the exponents. 5 to the power of 4 minus 6, and that is going to be 5 to the negative second, right? Now let's combine these two. If this is the same thing, right, this has to be the same thing as well. So 5 to the negative second is 1 over 5 to the second. That is what our rule is all about. So basically, any negative exponent is a fraction. and the fraction that shows 1 over that number to the same positive exponent. Let's try a different one and um, see if we are going to come up with something like that as well. So let's do 2 to the third power divided by 2 to the 10th power. Okay. Based on the rule of division of the numbers with the same base, different exponents, I'm going to subtract the exponents. 2 to the power of 3 minus 10. 3 plus negative 10, or 3 minus 10, is going to be negative 7, right? So I get 2 to the negative 7th power. Does that mean it's a negative number? Let's see if that is in fact a negative number. So I'm going to rewrite 2 to the third as 2 times 2 times 2, and 2 to the 10th. Okay, this way. And now I'm going to simplify my pairs that make one whole. And I get 1 over 2 to the 1, 2, 3, 4, 5, 6, 7th power, right? So 2 to the negative 7th means the same thing as 1 over 2 to the 7th, okay? Now 2 to the 7th power is a positive number, right? I can multiply 2 to the 7th power and get an actual positive integer. 1 over that positive integer is going to just make a very small fraction, but it's still a fraction and it's still greater than 0. So question is your quotient a negative number? It is not. It is just a small fraction that we are getting. It is a positive number. It is a positive rational number. Okay? 1 over the same number to the same positive power. So let's come up with an actual rule for it. Any number to the negative power is going to mean 1 over same number to the same positive power. Okay? This is the rule about our negative exponents. Let's see what it means in our lesson. Let's go ahead and try out some problems. I'm going to give you a time to work it out on your own and try to see if you can come up with any answers about numbers 1 through 6, and then we are going to get back together. All right, so here are the answers. Let's go ahead and just walk through them, make sure everybody understands everything. So exercise 1, 5 to the negative third power is the same as 1 over 5 to the third power. For example, I can just pick any numbers that subtracted would make negative 3, right? For example, 5 to the second divided by 5 to the fifth. And I can rewrite it and I can simplify it after that, and I will get 1 over 5 to the third, and that's how it happens to be. Exercise 2, 1 over 8 to the ninth is the same as 8 to the negative 9. You can even write it as 8 to the negative 9 over 1. This way you will be able to see that when we have this fraction, we can just flip it over and the exponent is going to change its sign. Okay. Example 3, exercise 3, 3 times 2 to the negative fourth is 3 over 2 to the fourth. How does that happen? I rewrote 3 as 3 over 1, and I rewrote 2 to the negative fourth as 1 over 2 to the fourth. And then I just multiplied across. 3 times 1 is 3, and any number times 1 is itself, right? So that's how 3 times 2 to the negative fourth is 3 over 2 to the fourth. Exercise 4, x to the negative third is 1 over x to the third. Exercise 5, 1 over x to the ninth is the same as x to the negative ninth. And exercise 6, xy to the negative fourth is x over y to the fourth. And again, this is an example how I did it. X over 1 times 1 over y to the fourth is x over y to the fourth. Okay, So these are the 6 exercises. Now let's go ahead and do exercise 7 together. Exercise 7. Write and complete expanded form for the decimal 4 and 728 thousandths in exponential notation. So let's take a look at this. So 4 is in the ones place, right? 728 thousandths. 7 is in the tenths place, 2 is in the hundredths place, and 8 is in the thousands place. So I can write that as, I will just show place value here. 4 is in ones place, and 728, 7 is in the tenths, 2 is in the hundreds, and 8 is in thousands. From earlier years, you know that I can write 7 tenths as a fraction, 7 over 10, right? 2 hundredths I can write as 2 over 100, so 7 over 10, 2 over 100, 8 over 1,000. And just like we did in the lesson 2 or 3, when we were writing numbers in exponential notation, I can rewrite 10 is 10 to the first, 100 is 10 to the second, and 1000 is 10 to the third, right? Based on our rule for negative exponents, I know that number in the denominator will have a negative exponent once I bring it to the numerator, right? So I can rewrite this as 4 times 10 to the 0th, because remember, for this is our ones place, and 1 is any number to the 0th power, times, oh, plus, sorry, 7 times 10 to the negative first plus 2 times 10 to the negative second plus 8 times 10 to the negative third. Again, notice these are not negative numbers. These are fraction. 7 tenths is 7 over 10 to the first, which is 7 times 10 to the negative first. 2 times 10 to the negative second is the same as 2 over 10 to the second. And 8 times 10 to the negative third is the same as 8 over 10 to the third. Okay, so that's how you write a number in exponential notation. This is not a negative number, this is a positive number, including decimals or fractions. What is the value of 3 times 10 to the negative fifth? So I just rewrote 3 times 10 to the negative fifth, and I turned it into fraction. 3 over 1 times 1 over 10 to the fifth, according to our rule for negative exponents. And then I multiplied across. 3 times 1 is 3. 1 times 10 to the fifth is 10 to the fifth. 10 to the fifth is 100 thousandths. So 100, 300 thousandths. Now, if I were to turn it into a decimal, I will get 0 and 100, 300 thousandths. That is the value of 3 times 10 to the negative fifth. Let's look at 3 times 10 to the negative second. 3 times 10 to the negative second is the same thing as 3 over 1 times 1 over 10 to the second, which is the same as 3 over 100, 3 hundredths. And if I were to put it into an actual number, the actual decimal number, I will get 3 hundredths. Exercise 10, last one here. Verify the general statement for x to the negative b power equals 1 over x to the b for x equals 3 and b equals negative 5. So I will put 3 instead of the x, and since b is negative 5, negative b is going to be positive 5. Okay, and that will be 1 over 3, and b is to the negative. So how can I prove that 3 to the fifth equals 1 over 3 to the negative fifth? And we know that every fraction is a division problem. So I rewrote that as a division problem. 1 divided by 3 to the negative fifth. Now, using our rules for negative exponents, let's transform 3 to the negative fifth into a fraction. 1 divided by 1 over 3 to the fifth. According to our knowledge of fractions, when we divide fractions, we multiply by the reciprocal, correct? So that means it's going to be the same as 1 times 3 to the fifth over 1. And when I have that 1 times 3 to the fifth, I know it is 3 to the fifth. So I just proved that 3 to the fifth is 1 over 3 to the negative fifth. So every time when we have a negative exponent on in the denominator, I can change it into the numerator with the same positive exponent, and vice versa. If I have a number with the positive exponent in the numerator, I can bring it down to the negative exponent in the denominator. Let's take a look at a couple more problems here. Now, exercise 11 and 12. So exercise 11 is 19 to the second divided by 19 to the fifth. So basically what that is 19 to the second minus fifth, right? And that will be 19 to the negative third. 19 to the negative third is 1 over 19 to the third. Okay? And then exercise 12, 17 to the 16th divided by 17 to the negative third. So that means that I need to subtract the exponents. 17 to the 16th minus negative third. It is important that you subtract negative third because it depends. It really does influence what your answer is going to be. You're not subtracting 3, you're subtracting negative 3. That means you're going to add them, right? 17 and 16 plus 3. That makes 17 to the 19th power. So that sums up our lesson 5. Next one is the problem set, and I will talk to you in class.